hear me? Yes. Okay, my name is Keshav and this is our presentation. And basically, what it is, it's about debugging. It's something that you could say it's mostly common sense, but the thing is, while there's a lot of knowledge and resources on the internet about how to set something up, like how to code something, there's not all too much about how to make it work and make sure it works in competition. So yeah, that's what this is about. So yeah, the problem is pretty simple here. It's that what happens in a practice doesn't usually happen in a match. Okay, but basically the issue is that there's a lot of human error. There's a lot of what we call edge cases, and the way we think about that is think about the fields and how they're different. So if something barely works at your practice field, there's a good chance when you move it to a match, it doesn't actually work. And then there's of course field differences and calibration errors. And essentially what happens is you encounter problems in these matches that you're not really having in practice. So here are some videos. I don't know why they put it already, but it's basically us missing the specimen this year. Yeah, it should be a little bit better, but yeah, if you can see the bottom video, you can see us really missing multiple times in a row. It's really funny in hindsight how bad this worked in this match, but how well it worked in practice. And that's really the problem. That if something like this happens, you should be able to fix it for the next match. So firstly, to have a setup where you can solve problems on the fly, you have to be prepared before the tournament. Basically check all libraries and code that you don't really know. And I mean, it's pretty self-explanatory, but know your code. Because if you're running code that you really don't know, if it breaks, you don't really know how to fix it. But yeah, one thing that I would like to note is that there's a big difference between a practice and a match, and that's how many robots are on the field. There's three more robots in a match, which means that essentially a robot hasn't been stress tested with any of those shocks. So you should be checking your robot for those sort of shocks and how you can respond in sense of power draw and all that. So yeah. So the first step to debugging a problem if it happens is to identify the problem. So just take a look at this video here. This problem, it's pretty obvious what's going on. But a lot of teams will jump to conclusions, and it's very important that you only keep the facts. So in this problem, specifically, you can see it's not picking up the pixel. So that you have to get down to the facts and not jump to a conclusion. And if it's a one-time problem, it's likely a software issue. If it's a problem that's happening multiple times, it could be hardware. And it's important to make that distinction because if it's a software issue, of course, it's for software to handle, but if it's a hardware issue, it's important that you don't compensate by making easy fixes because the issue with making software fixes is that it could create another problem that you don't know. So yeah. And then the second step is to find exactly what the error is. So not what happened, but why it happened. And there's two types of problems that it's pretty self-explanatory. One is numeral. They're both logic errors, but numeral is basically when you have one number that's wrong. So the amount of inches you go or an encoded value. And numeral values usually happen due to field differences and miscalibration. And you can use the match footage and practice field to solve for those. Logic errors are basically errors where you don't know what happened. It's a significant core of your functionality that's broken. And the issue with logic errors is that those ones usually take time and they happen at the worst time. So for us, we had a lot of logic errors when it came into our early deep meets because our software would simply break. So the reason why logic errors happen is because in a practice field, in your own practice, the code was barely working. And when you took it to the match, that broke the robot beyond what it was meant to do. So this is basically a field difference, stopped the robot from working. And yeah, that's about it. And then there are some common culprits. So if you can see this clip, you can see essentially how we're scoring fine for the first two. And then, oh, sorry. This quickly. Okay, so the first two scores, you can see it's relatively fine, like nothing wrong with the robot. But just watch how the third score differs from this. And this is one that's pretty common. That's an issue with power draw. So we didn't have enough power to complete that. And yeah, power draw is a huge issue in these matches because in matches you tend to draw more power in a solo match. And like anything with sensing and power draw, like you tend to have issues there. So how do you solve the problem? So with power draw, the way you want to check it is firstly you should know the voltage demand of each subsystem. And I know this goes like without saying, but like each of the subsystems, like anything that moves is drawing power. And in a match when you're at low battery, some things may not work the way it does. So how you want to solve that is you want to split joint actions. So say with this robot here, if you guys can see that, you're moving out and you're moving these two servos. So that's one motor and two servos moving at the same time. If you simplify that into one by one, you could make it happen. Like you basically want to split a task that's involving multiple motors into one motor, so that you don't have a lot of power at the same time. And then you want to disable like some PIDF. So say you have ongoing PIDF with a feed forward component that's holding up like a linear slide. So if it's holding up the linear slide like this, it's actually drawing power, even though we don't realize it. So if I let go, it does sag down a bit, and that's the power that it takes to hold it up. So a lot of times, these sort of PIDF programs, like you'll have it, but they draw power, and if you disable those, you can fix it. And then another way you can do it is you can test whatever solution you have on low battery. Then when it comes to margins, so margins are basically problem where it works, but only sometimes like you're pushing the margins, and that mainly comes with encodability. So say you need to score, and the position to score is right here, and assume in the match it goes there, and your margin of error basically it's basically an error with encoders, and you want to use the telemetry or logs to help debug where you need to go. And if you can, you should be able to widen the range. So one issue we had in the Charlestown event was our autonomous stopped working because when the slides went down, all the way down, the robot never set it right. And because we have a tolerance, so if the encoder goes down to say a position slightly above 0, it counts it as going all the way down. But when it didn't happen, it just created an infinite loop. So you want to check all your margins. And then the last part is sensing. So depending on where your team's at, you either use sensing in Teleop or you like don't. You use a lot of sensing or you don't. And in this clip, we use a color sensor. I don't know how well you can see it, but do you see how the arm bounces for the first time? And that's because the claw is not able to properly sense the sample. Because a lot of sensors and cameras you need to recalibrate to the field for lighting differences, or you need to modify the threshold. So for this specific clip, the amount of blue that we were sensing was too much. So it was not able to actually meet in the range of what we consider a sample. So we really need to debug. You need to debug why it's happening. So if you notice that the lighting is different, then you can really check it. And when you have an issue with sensing, make sure you check for the other alerts. Because if you have an issue with blue, you may not have the same issue with red. And then the last thing is, of course, you want to test for it. But what happens when you test things and it doesn't work? That's when you come with backup strategies. And basically, you want to dumb down the problem into working solutions. So in this clip, you'll see us scoring without using our crane. This was in the FT League tournament where we had issue scoring, and we basically said, okay, we're just not going to use this crane. And that's what we ended up doing. So instead of trying to find a solution with hardware or software, you can actually change your strategy of how you drive itself to fix the problem. It doesn't really fix the problem, but you're just avoiding it. So yeah, you really want to, if you don't have an option that works, you want to reassess and yeah, dumb down the problem if it happens. So now we have a little bit of a demo for you guys. So basically what I did was I took our intake and I basically broke it a little bit. And what I mean by that is, yeah, I basically made it not work and I realized we do not have a sim. I'm sorry, I don't have one. We have a sample. Oh, you have a sample? Okay, so this is a sample. For those who don't know, this is challenge. There are many of these on the field, and you have to pick them up. And what happened is we've had some problems picking it up. And this is one set of problems. So this upload is currently running on the robot right now. And all right. Okay. So let me reset it and then we can. All right. Okay. So essentially, there is one button we have to pick up the sample, and essentially it doesn't work. So now the challenge is, why does it not work? So that's the little bit of debugging that we're doing live. So I've intentionally broken it in a few ways, and yeah, it's up to you all to see if you guys can figure it out. So I have Android Studio running, and yeah. So did you break the software or the hardware? I broke the software. So all of this was about software debugging. So yeah, the hardware is fine. It can pick up. So here is picking up. I think it's pretty obvious why we pick it up. Does anybody know why?
The measurement of distance.
Sorry?
The flaw in the piece.
Yeah, it's not going down enough, right?
So maybe the functionality was the road to pick up the task was not working.
Exactly. So it's not going down enough. But even if it is going down, so I can change that very quickly. That's one issue with it. Sorry. Can you all see my screen? Oh wait. No. Oh. Okay. Okay, so exactly, the first issue that is that it's not going down enough. There is an issue. I'm not able to share my screen, but that's okay. Basically, the issue that we're having is that it's going to the wrong position. So I can fix that very quickly, and then we can see if it does work. So, okay, I'm uploading codes. Ideally, I would be able to share the screen, but yeah, that's one issue. But that may not be the only issue with why it's not able to pick up. So right now, the program is stopped. Yeah, sorry about that. Ideally, it would be shared, and you guys could be able to watch the code, but it is what it is. Okay, so now the latest code is on the robot, and I fixed the problem of it. I made it go down just a tad bit more, like 5% more down, and hopefully that does fix it. But if there's another issue, again, it's another test. Okay, so we're back. Why did we not pick up there? I can do it one more time. Can you all see this well, or is it difficult? So I'm going to pick up again. Why is it not picking up? I mean, I know it's any ideas?
You gotta turn the thing, right?
The claw?
You gotta turn the claw or.
No, the claw has the right position. So if we turn the brick.
Whatever you do in the functionality to pick up the piece is not appropriate.
Yeah, exactly. It's broken, but what about it needs to be fixed? It's just one small line of code. Yes?
Does the claw close too soon?
Yeah. Does it claw close too soon? So it picked up then. So this is what I mean by margin. So it works a few times, but when it comes to the tournament, it just stops working. So again, yeah, so now it starts working. So what's the reason why it's not? What do you mean by too soon? Like, what do I need to increase or decrease?
I just try to put a weight to the coding line.
So when it goes down and then close it?
It goes down close and then before it.
Okay, so now I can go down, and now you're saying it closing too soon?
Yeah.
Okay. Yeah. Okay, so yeah, that's exactly right. We're not going down and waiting it up for the claw to close. So when we quickly do it like this, we're not exactly catching the sample as we need to. So I know this wasn't really a great demonstration.
Yeah, but you, so, it's because you're running sequential code, because it's a robot, you said, go down, close the claw, lift. Well, when you say close, when you say move the servo to here, you started that process and immediately goes to the next line of code, which in your case is lift up. But the servo takes time to move.
Exactly, sir. That's what I did. So yeah, I think what you said was great. So that's but that's exactly what I changed. So it goes down correctly, but it doesn't. While the claw is closing, it needs to stay there for some time. Because once the claw starts closing, and then it keeps moving. So there needs to be a wait. So that's exactly what I changed. And then exactly once I change that, you get this. And then right here. So yeah, that's exactly it. I know this wasn't the best demo, but the point is, I think a lot of times code is broken, and we should be pretty good to like fix it on the spot. And yeah, that's about it.
So the other way to fix that would be if you're using like the axon servos that have the fourth wire, you can sense that the thing has closed.
Exactly.
Because you don't want to waste more time on a wait. You don't want to wait a half a second for it to close because now you're serving your cycle time.
Exactly. Yeah. There are multiple ways, but yeah, the key is to like debug when something is going wrong.